Now, good morning, all of you. Today, we are going to begin a very important chapter in mathematics, that is trigonometry. Now, see, from the word itself, it is very clear. If you see this word trigonometry, then what all things we can see here? It comprises of three different parts. That is, we have tri. First part is tri. Then we have got gono, then we have got measurement, that is metry. So tri means three sides measurement. So this is what trigonometry is, the measurements of the three sides of a triangle. This only we are studying in trigonometry. So measurement of three sides, what? So not the measurements exactly how much centimeter of the different sides are. Yes, that is, we are measuring the sides of the triangle, but we are here in trigonometry we discuss about the different ratios of the different sides of the triangle. Now you all know what is ratio. If I say ratio, if I draw here one line AB and the other line if I draw here CD, then what does ratio means? Ratio means AB upon CD, or the ratio can also mean CD upon AB. So this is the ratio. When we divide any two different lines, then the things which we get, that is called ratio. This is called AB by CD is the ratio, CD by AB is a ratio. Means two lines we can take ratios in the two different way. In this case, AB is, in one case AB is the numerator, then the other case AB is the denominator. Similarly, in case of a triangle also, if we take the sides ratio, then the ratio of two sides will be taken in two different way. If the one side is on the numerator side, then the other side will again become the same side will again become the denominator. So this is the ratios. So in case of a triangle also we take the same ratios. We take the ratios of if I talk about the triangle, right angle triangle ABC, then the ratio means AC upon AB, BC upon AB. So in trigonometry we study this only, like we have taken here AC upon AB, then this again can be written as AB upon AC. Then again this can be written BC upon AB. The same again can be written here, AB upon BC. Then the other is AC upon BC, and again we can take in the reverse order BC upon AC. Now see, these things only we study in trigonometry. I will say, sir, this thing the only AB by BC, BC by AC, or this thing, but we study a different thing also in trigonometry, sine, cos and all. Now see, these are the different ratios of the different sides of a triangle. And how many ratios we are getting here? Two sides, two ratios we are getting. These two sides, two ratios we are getting. Means total we are getting here 6 ratios are there. Now two sides, two ratios means what? If one side is AB by AC, then again the reverse is AC by AB. So in that way we are getting the 6 different ratios of the triangle ABC. Now come to the trigonometry part. Now this was just the ratio I was discussing. This trigonometry we are only dealing in the right angle triangle. That is, right angle triangle means one angle is 90 degree. Of course, in a triangle only one angle will be 90 degree and the other two angles are acute angles. So this right angle triangle we talk about the different ratios of the sides. Now see, AC upon, in this right angle triangle we assume, not assume, we are taking this AC as perpendicular and this we are taking as base, and this it is hypotenuse. So here what we are doing here, AC upon AB, this ratio we can also write here perpendicular by hypotenuse. Can we write here? This we can also write perpendicular by hypotenuse. From here, AC upon AB, AB upon AC. Now just the numerator becomes denominator. Then BC upon AB, that is, this is B upon H. Then again it is H upon B. AC upon BC, that is P upon B. Then this is B upon P. Right? These are the different ratios which we can get. Yes, we say the ratios of the different sides. So I have written here the ratios of the different sides of the triangle. A ratio of the different sides of the triangle. Perpendicular, hypotenuse and base. Now these ratios are only given name. Now what name it is given? This perpendicular and hypotenuse has been given a name sine. I am not talking about theta because I am not taking any particular angle. This is ratio is given sine. This base upon hypotenuse is given cos, and this is given the name tan. Okay, sine, cos, tan. Now this perpendicular by hypotenuse is sine, and when we take the reciprocal of, when we take perpendicular by base, we take the h hypotenuse by perpendicular, then this is called cosec, this is called sec, and this is called cot. Right? So the different sides ratios are given the different names in a right angle triangle, and these different names are sine, cos and tan. Sine, cos, tan are nothing but the ratios of the different sides of a triangle. So ratio of perpendicular and hypotenuse is called sine. Then we get base by hypotenuse is called cos, and then perpendicular by base is called tan. Keep in mind, remember this thing, this is very important. Now this cosec is nothing but the reverse. Basic is perpendicular by hypotenuse, that is sine, and the reciprocal, that is hypotenuse by perpendicular, is cosec. Then hypotenuse by base is sec. Then this base by perpendicular is cot. Perpendicular by base is tan, and base by perpendicular is cot. Means these are, if you see, then these are the basics 3. 1, this is 2, and this is 3. These are the 3 basics trigonometric ratios or T ratios, and the other 3 ratios are based on this basic ratio. If I take reciprocal of the sine, then it becomes cosec. If I take the reciprocal of cos, then it becomes sec. If I take reciprocal of tan, reciprocal or inverse of tan, then it becomes cot. So now we will also talk about theta, because this sine only we have not heard, or you also must be thinking ki sine only sir is saying. We generally hear the word sine along with the theta. Sine theta we said, we don't say sine only, but sine is the ratio is given the name sine. Theta angle we are taking. Now why we are taking the angle, we will discuss right now. Now see here, in this right angle triangle, if I say this is perpendicular and this is base, I have written here, but there if I say I want to take this as perpendicular and this as base, then why can't we take, we can also take this as perpendicular, and we can take this as base, because it also makes a 90-degree angle, this also makes a 90-degree angle. So this also can be taken perpendicular, this also can be taken perpendicular. Now how to decide which perpendicular we have to take? If we are taking the ratio, and if suppose if one student has taken this as perpendicular, I have taken this as perpendicular, and the other student has taken this as perpendicular, and they have taken this as base, then the whole of the trigonometrical ratios will change, and I cannot say that student is wrong, he is also correct, because he is also taking, we can take that also perpendicular. Then who will decide? Who will decide which is the perpendicular? Who is the hero who is going to decide okay sir, who is the boss who is going to decide no, he is this side will only be the perpendicular, dear, you don't have to take this side, don't beware of taking this side. Who will decide? Who is the boss who is going to say? Now that boss is the angle, that boss is the angle, that is what we say as theta. Now how this angle decide the sides? Now see here, if I say here, suppose if I am making this as theta, this angle I am taking as theta, then what will happen? The moment I have taken this angle as theta and I have to find out sine theta, then the rule says that whenever we are taking any angle, then the side in front of this angle will be perpendicular, and the side adjacent means which is along with that angle is base. So this is the boss who is going to decide which is perpendicular and which is base. So now there is no controversy over perpendicular and base once I have taken the angle theta, means angle B. If I have taken this angle theta here, that is angle B, then for angle B this is perpendicular. If suppose if I take here angle A, if suppose if I take this angle A, then the theta will change. Now for angle A, the theta, for angle A, the perpendicular will change. Now for this angle A, the perpendicular will be BC. The side in front of the angle which we are taking, that side is considered to be perpendicular, and the side adjacent to the angle, adjacent means along with that angle, is considered to be the base. Now even though we don't know what is base, but once when the perpendicular side is clear, then automatically the base also becomes clear, because hypotenuse is hypotenuse. Hypotenuse never changes. This has got a different status. It is hypotenuse which has got nothing to do with the changing. It is always hypotenuse no matter which angle you are taking. So only the perpendicular and base changes. So this base becomes perpendicular once the angle is changed. So here if I say here, this is suppose if I write here theta, and this if I write here suppose if I write here phi, one I have taken theta, the other I have taken, or don't take phi, make it different, beta, theta, beta. So if I write here trigonometrical ratios, now see, if I write here sine theta, then if I write here sine theta, then for sine theta this is perpendicular, then we can write here sine theta is AC upon AB, then cos theta is BC upon AB, and tan theta is AC upon BC, perpendicular by base, AC upon BC. Now here again if I take here, suppose I have taken here sine theta, if I take here sine beta, if I take here sine beta, for beta this is perpendicular and this is base. Sine beta, this is perpendicular, so for sine beta sine beta will be BC upon AC, perpendicular by perpendicular upon base. Then cos beta equals to, now cos beta is base by hypotenuse, that is AC upon AB. Then tan beta equals to perpendicular by base, that is BC by AC. Now there is nothing to confuse. Why? The different ratios of the different sides will automatically change with the change in the angle, because the angle, the side which is in front of the angle, that is perpendicular. So in this case of a theta, the side in front of the theta is this AC. So AC is perpendicular for theta. So whenever we take sine theta, then it is AC upon AB. Sine theta, sine is perpendicular by hypotenuse. Cos theta BC upon AB, that is here base by hypotenuse, and tan theta is AC upon BC, AC upon BC. But now this again changes when I take here beta. Then what is the perpendicular here? BC, and what is hypotenuse? Acha, AB. Sorry, perpendicular by hypotenuse, that is BC upon AB. Now cos beta is this AC upon AB, tan beta is BC upon AC. Now it looks little confusing, in the diagram when I am taking both theta and beta, then it becomes little like a confusion kind of a thing is there. You don't need to be confused. In the diagram it looks like that. Just keep in mind that whatever angles you are taking, the sides in front of the angle will be perpendicular and the side adjacent to the angle will be the base. Only you have to keep in mind the side in front of the angle is perpendicular and the side adjacent to that angle is base. The side in front of beta is perpendicular, side adjacent to beta is base, and on the basis of this we find out the different trigonometric ratios. Now in next class we will be studying about the trigonometrical values, the ratios value of the different angles, like when the angle of theta is 0 degree, when the angle theta is 45 degree, 30 degrees, 60 degree, then what will be the value of the different t ratios. Just have a look. If you have got any doubt, you can ask me. Thank you.